So in December 2011, scientists noticed from spacecraft observations that there was a sun-grazing comet coming very close to the sun. And a sun-grazing comet is a general term for a specific type of comet that will have a perihelion or minimum orbital distance very, very near the sun. And it's thought that these comets represent smaller fragments of a parent body that may have come close to the sun and broken apart some 15 to 1600 years ago. And so every 500 to 600 to 700 years later, we'll see parts of this comet come around. Comet Lovejoy came within about a tenth of the solar diameter, which is very close to the sun and within the atmosphere of the sun that we call the solar corona. And you can see in these coronagraphs observations this comet coming slowly and then quicker and quicker and then passing very quickly by the sun. The fact that Lovejoy survived its passage to the sun was very interesting. Typically these comets fragment very, very near to the sun's surface due to the harsh radiation environment. What was very interesting to solar physicists, people who study the solar corona, was that the tail of Comet Lovejoy seemed to exhibit very unusual motions. It wiggled in some places, and the motion of the tail was very unexpected if you don't consider the sun's magnetic field. And that's what we did here in this work. Perhaps the most unexpected thing about Lovejoy's passage was that we saw it in the corona at all. This was only the second time we saw a sun-grazing comet produce emission that was visible in extreme ultraviolet wavelengths that we typically observe the sun at. One thing we noticed very quickly is that the wiggles or the motion of Comet Lovejoy seemed to suggest that it was mediated by the invisible magnetic field of the sun. And so ionized plasma must flow along the magnetic field lines, and it seems that the tail plasma coming off of Lovejoy was becoming heated by the hot solar corona and then following the magnetic field of the corona. And this was very interesting to us as solar physicists who want to understand the corona. The magnetic field of the sun can produce space weather, and what governs the solar wind that is continually flowing by the planets, including Earth. And so we have a sophisticated computer model that we use to try and understand the coronal magnetic field and plasma structure. And from this model, we took our magnetic field, and then we traced the local magnetic field along the orbit of the comet. And from this, and a simple physical model for how we think the ions coming off, the plasma coming off of the tail should interact with the magnetic field, we were able to predict the motion of the cometary plasma.